Hello guys, we have already done substitution in last few lectures and today we are going to start elimination reactions. Elimination reaction will have different category of reactions E1, E2, ECB. We'll understand all of these in detail. So let's start. When we are talking about the elimination reaction, I hope you understand what does the elimination means. Elimination means the removal of a molecule from the bigger carbon chain. So when we say that elimination is happening, elimination happens from the adjacent carbons. It can happen from various different places in the carbon chain, but the most common what we face is when the carbons are adjacent to each other and two species are getting removed from those adjacent carbons. Let's take an example. We have a chain like RCH2, CH2X. I can also write this as RCH, CH2X. Now this carbon is called as alpha carbon, where the haloalkane, where the alkyl halide is present, and this carbon is called as a beta carbon. Now, when the removal of this X from alpha position and hydrogen from beta position will take place, the molecule which will formed will be RCH double bond CH2 and removal of HX will happen. So this removal of HX from the molecule and the formation of alkene will be called as elimination reaction. Now this elimination which I have shown you, that can have different names. This reaction can also be called as alpha beta elimination. Why alpha beta elimination? Because one species has got removed from alpha position and another species has got removed from the beta position. But you will find in many books this reaction written as only beta elimination. Why? Because we are more focused upon the hydrogen present on the beta position, because X was anyways we had a plan to remove. When the nucleophile is attacking or a base is attacking, it is going to replace this X in some manner. But now when the hydrogen also gets removed and the compound becomes alkene, then the role of this hydrogen comes into the picture, which is on the beta position, and hence this elimination is called as beta elimination more often. Now when we are talking about this beta elimination can also take place in various ways. First way, when when your X minus is removed first, and once the X minus will go out, a carbocation will be formed at this carbon. So when X minus is removed, carbocation will be formed, which will rearrange, and then this beta hydrogen will be removed. Then this beta hydrogen is removed. When the process takes place in this direction, removal of X first, formation of carbocation, rearrangement of the carbocation, and then removal of hydrogen, then the reaction is called as E1 reaction. Next is when hydrogen and X both eliminate simultaneously. That means both are breaking their bonds with the respective carbons and forming alkene. So in this case, the bond between hydrogen and X both will break together, and the new bond will form between the beta carbon and the alpha carbon. So this whole process will happen in one transition state itself, and this reaction is called as E2 reaction. So I hope you remember what was SN1 reaction and what was SN2 reaction. So in SN1 reaction also the carbocation used to form and then the nucleophile used to attack. So the first E1 reaction is following the similar pathway, and when we talk about E2 reaction is also following the similar mechanism as SN2. In SN2 the incoming nucleophile used to attack and the leaving group used to leave simultaneously. So bond formation and bond breaking both used to happen at the same time. So very similar situation is happening over here. Hydrogen and X both are breaking their bonds with the carbon, their respective carbons, and alpha and beta carbons both are forming a new bond between each other, forming an alkene. So this reaction is called as E2 reaction. Now what is the third case? Third case is when hydrogen is getting removed first, forming a carboanion. Hydrogen is removed, forming a carboanion. So this carboanion will actually act as a conjugate base. Right? And this hydrogen will be removed, forming a carboanion, and then removal of X will take place. So this is again two-step process. This is again a two-step process where the removal of hydrogen is happening first and then removal of X is happening. Because here the conjugate base forms, this is the reason why we call it even CB. The reaction is called as even CB. What does the even CB means? Even CB means even conjugate base or elimination conjugate base. Because the process is similar to even, where the removal of one species happens in the first step and the other species happen in the second step, but it is going through a conjugate base formation. That is why it is called as elimination conjugate base. Now other two things what we have to remember when we are talking about an elimination reaction happening. First is, whenever we are talking about elimination, it will always happen in the presence of a base. It will never happen in the presence of a nucleophile. So your species, your attacking species should be a base rather than a nucleophile, or it should be a better base rather than a good nucleophile. And second thing is, elimination reaction will require heat. So that means you need minimum temperature of 60 to 70 degree for reaction to take place. So what are two mandatory conditions? First is base presence, and second is temperature required, which should be minimum 60 to 70 degrees of temperature. This is the mandatory condition for any elimination reaction to take place. Okay, so next we'll talk about even reaction for Rx, where X can be any kind of haloalkane, can be any alkyl halide. So let's see what is elimination, what is even reaction for Rx.